welcome back to Young Engineers of Today. I hope you had a good holiday. Well, Halloween. Hope you enjoyed it, had fun, did neat things. Hope you're ready to continue with Arduino because that's what we're going to do. Now, refresh my memory. If I remember correctly, we finished with the multiple LEDs. Oh, gotcha. That happens. We finished with the multiple LED circuit. So we got the 8 LEDs blinking in sequence and all that good stuff. But I believe that was the last thing we did. Yeah. Okay, so that means that for today, we're going to continue with Arduinos. But now we're going to look at the other side of the coin. So far, all we've done is mess around with output. Today, we're going to mess around with input. So now, between those two things, you can have a fully functioning something, gadget, whatever. You can take an input and have it trigger output or affect the output. So you can drastically increase the complexity of your Arduino circuits. So with that in mind, I'm going to go ahead and I am going to open up circuits.io again. And let's see here. Oh, nice. Excellent. So you get to mess around with that. That's pretty awesome. All right, so go ahead and create a new one. Given asset ID does not exist. Interesting. Well, I'll just click edit here and that should bring me into it. And that's not it. That is one that already exists for other class. I mean, your choice, but it wouldn't be a bad idea to get it done on the website, just because you don't have to set up the communication between your computer and the Arduino. In case you haven't done that yet, sometimes there are things that are finicky about that. So I'm using the website so I can show you guys what we're doing, but really, literally, it is your choice. Just keep in mind that if you use the real Arduino, sometimes there are communication issues between it and the computer that you have to troubleshoot, which is something you don't have to deal with the website. Okay, so like I said, we've been using outputs on the Arduino. We haven't messed around at all with inputs. That's what we're going to do today. We're going to spend some time messing around with inputs. We're also going to take a look at the serial monitor, which is something that exists and is useful for basically taking a look at what's going on inside of the brain of your Arduino. The idea here is that just like anything, a generally useful machine is going to do something based on its inputs. It's going to, the output is going to have some sort of influence from the inputs. Otherwise, we have something that just does something kind of neat, like LEDs that blink, or we have something generally kind of useless. I mean, there are things that operate without any input, technically speaking, like a fan. Once you turn it on, just does its thing. However, generally good fans have different speed settings and stuff like that based on input from the fan user or the temperature or something like that. Lights, you turn them on and they just stay on and they light things up. Stoves and ovens, you turn them on, well, stoves certainly, you turn them on to a setting and then they just heat stuff up. So, there are useful things that don't continually ask for input necessarily from a person. But by and large, when we're talking about more complex things, we also want to have the input have some sort of change somehow because excuse me, have some sort of effect on the output. Once we know how to read it, then we can do other stuff. So a couple of the things that I wanted to go over today are the difference between analog read and digital read, because those pins exist on your Arduino, and then the serial print function. Now again, all this stuff can be done with either your real Arduino or the websites. However, the website you won't have to worry about having the Arduino communicate with the computer. If that's something you've already handled and you know that you have no issue communicating with the Arduino and you have all of your components handy and stuff like that, you're more than welcome to use the real Arduino. But yeah, anyway, so analog read and digital read are two separate versions. No worries. We're just going over input. So we're just going to HTML5 viewer user. Interesting. That is an interesting name. Sorry to hear that Windows broke on your computer though. But yeah, so we're going over input now for the Arduino. I was just about to go over analog read versus digital read. Does anybody here remember the difference between analog and digital? Anybody? How about what's digital? Okay, how about this? What do you think of when you hear the word digital? Clocks, okay. Computer, okay. Computer, got another one for computer. What does a digital clock look like? Over the internet, yeah. Boxy and radio, okay. But how do you read the time on a digital clock? As opposed to? So, right, in numbers as opposed to hands, yeah, exactly. How about a computer? What language does a computer use? Okay, binary. Code is the language we use to speak with the computer, but even then that gets translated into something that a computer can understand. But a computer speaks in binary. Binary, how many values are in binary? All right. Digital also has two values, either on or off. That's why we refer to anything generally that has to do with computer as being digital, because a computer speaks in a language that has only two values, either on or off, 1 or 0. So remember, digital is either full on or full off. There are no values in between that it can read. Analog can read full on or full off, but it can also read all of the values in between. So, if we're talking about being able to send anywhere from 0 to 5 volts, digital would be able to send 0 volts or 5 volts and nothing in between. Analog could send 0 volts, it could send 5 volts, it could send 3.5 volts, it could send 2 volts, it could send 1 volt, it could send 4.789 volts, it could send 4.99999 volts if you wanted to. So analog has an infinite number of values that it can send out. Even between a range of two numbers, between 0 and 5, it can send out an infinite number of values. Technically speaking. Realistically speaking, there's not going to be much of a difference between 4.01 and 4.001 and 4.0001 and 4.000001 and so on. Most of the time, a lot of things will just interpret that as 4 for sake of, for ease. But anyway, that is the difference between it and digital. Digital can only send or receive two values, on or off. Analog can send or receive an infinite number of values. An analog clock has a face with hands on it, and those hands turn. And those hands, you'll read the time, you'll be like, oh, it's 3:15. But the minute hand could be halfway between 15 and 16. And an analog clock will show you that. It could be 3/4 of the way between 15 and 16. If that second hand moves smoothly and it doesn't just like move to the next second and then stop, it could the second hand could be in between seconds. A digital clock is not going to show you that. If it's 3:15 and 3/4, it might say 3:15 and 45 seconds if it shows you a seconds readout, but if it's just showing hours and minutes like most digital clocks do, it's just going to read 3:15. You don't know how close to 3:16 it is. With an analog clock, even if it doesn't have a second hand, you could get a pretty decent idea of how close you are to 3:16 just by looking at the clock. You could get a pretty decent idea of, even if an analog clock just had an hour hand and nothing else, it would be kind of annoying to read. But you could look at it and see like, oh, okay, so it's past 3, but it only looks like it's about a quarter of the way towards 4, so it's probably about 3:15. So you'd be able to read it then too. Imagine how annoying a digital clock would be if it only showed you the hour. What time is it? I don't know. It's after 3. Could be 3 though. Who knows? It could almost be 4. I have no idea. Yeah. So that is the main difference between the two. That is the difference between the two, in fact. Just to reiterate, analog can send an infinite number of values, can send and receive an infinite number of values, and digital can send and receive only 2, on or off. So with that in mind, we're gonna, we'll show off analog read on the circuits.io, just because why not? So it will have us use a light-dependent resistor. We'll test that out. We can always replace it with something else just in case an LDR doesn't work on circuits.io. For those of you at home, it will certainly work as long as the LDR works. But that's what this is. An LDR is a light-dependent resistor. It's also known as a photocell. You know how here it says photocell, also known as a light-dependent resistor. I flip them around just because blah. Anyway, the resistance of an LDR decreases as the light source, basically the light shining on it, increases. So the brighter the area around the LDR is, the worse of a resistor it is. The darker it is, the better of a resistor it is. You can probably think of a few things you can do with that. You can have a light detector. You can have a night light. You could have the lights in your room automatically turn on when it becomes sundown. That kind of thing. That's what an LDR can be good for. You can have a motion sensor for very, very close motion. Basically, if a shadow passes in front of an LDR, it can increase the resistance, force the electricity to go down a separate circuit, and set off an alarm or something. You know, who knows? We actually used an LDR in a robotics project a few years ago, where the robot had to pick up green pegs and leave red pegs alone. Or no, it was the other way around. Pick up red pegs and leave green pegs alone. And we used an LDR for it. Because here's the funny thing. So here's our LDR, right? If light hits it, it becomes less resistive, so electricity flows through it. But that's the full spectrum of lights. Can everybody hear me okay? Okay. Okay, just wanted to make sure because for some reason GoToWebinar was saying that my internet might be terrible right now. Anyway, it senses the full spectrum of light. It doesn't distinguish color because like white light is all of the other light, right? It's everything else put together. And they've proven that with the whole, famous picture of the prism where you shine a... The sound is a bit glitchy. That's no good. Wonder what could be causing that. I don't think it's my computer. Well, let me know if it gets really bad. You guys feel free to say something in chat. Anyway, who here remembers that famous picture where it's just like a prism? Pink Floyd used it for an album cover, but it's also a pretty famous thing in its own right. Yeah, Dark Side of the Moon, you know it. But yeah, essentially, white light comes in one side, and a rainbow comes out the other, and it's a pretty famous sort of experiment which proved that white light was made up of... Yeah. Anyway, it's a pretty famous experiment which proved that white light was comprised of other colors of light. So that doesn't really do us any good if we've got a green peg and a red peg and we're supposed to distinguish between the two. But here's the funny thing about it. It's pretty easy to split light, or at least only let certain types of light through, certain colors of light through. Get a piece of red plastic, like a see-through piece of red plastic. Woo! You look through it and the entire world looks red, right? Well, that's because this piece of see-through red plastic, thank you, it's wonderful, I think it is wonderful plastic. This piece of see-through red plastic is only letting through red light. Any other color of light, for instance green, is just going to bounce right off. So things that don't have any red in them are going to appear much darker through the red plastic as well. The funny thing about objects that are painted, so like something with red paint on it, it just bounces off. It doesn't go through. And then I guess it's presumably, it's either absorbed or bounced off. It could be absorbed as well. In fact, who knows? In fact, I don't think it'd be absorbed, though, because if it was absorbed, the energy would have to go somewhere. It's not like the energy just gets destroyed. It's something I'm a little bit unfamiliar on. But anyway, the funny thing about something that's painted is the reason why it appears this color, for instance green, is because green is the color it reflects. Red gets absorbed. The opposite is true of a red peg. Green would get absorbed. So it appears red to us because the red light bounces off of it. So now, imagine we've taken our red cellophane, we've placed it over the LDR, and we shine white light onto a red peg. The red light, the red light is going to bounce off of it, and it's going to be able to go through the cellophane. If this were green, it would bounce off of it, or excuse me, it would get absorbed. It would get absorbed, so there would be no green light going in. However, if green light bounced off of it, if this were a green peg, it would not go through the red cellophane. Thus, the only light that's getting through to the LDR is the red light. So we're able to use something like an LDR to be able to tell different colors just by sticking a piece of colored plastic over it. It's kind of cool. Um, anyway, yeah. So those are just some things you can do with LDRs. Now, the thing about an LDR, let's take a guess here. Its resistance decreases as its light source increases. Based on that description, do you think that makes it analog or digital? Yeah, exactly. Analog. Um, precisely. So it's an analog. Okay, it's an analog component. Produces an analog result. So let's go ahead and mess around. Precisely. Let's go ahead and mess around with this first circuit. Okay, so we're going to need an LDR, obviously. We're not going to use an LED yet. We will set up an LED eventually, but we're not going to use an LED yet. And we are going to need a 10,000 ohm resistor. So we need an LDR, and we need a 10,000 ohm resistor, as well as some jumpers. So I'm going to go ahead and grab that stoof. LDR. Boop. Drag out a photoresistor. Resistor. And then I'm going to grab an Arduino. And there we go. Those are all the components we need right now in order to be able to do our first circuit. So I'm going to change this to 10,000 ohms just by putting a 0 here because it's already listed in thousands of ohms. So you should have a orange, black, and brown, or rather brown, black, and orange set of bands on the resistor. You can confirm it right here, brown, black, and orange. All right, so I'm going to hook up my LDR. So it is straddling two separate rails, right? We do that in order to avoid short circuits. This is a weird way to set it up. And then I'm going to have the resistor, the 10,000 ohm resistor, run from one of the legs to the negative rail. Does it matter which leg? Not really. Doesn't matter which leg. Because resistors are non-polar. I've probably brought that up before, but I'll just say it again just to reiterate. Resistors are non-polar. It doesn't matter which way you orient them. They're happy being resistors regardless. I'm going to set this up right here and flip this around just so we have more control. Ah, that's why they did it. I see now. Okay, change of plans a little bit. You'll notice I still have the resistor hooked up to the LDR, but I turned it sideways. So now it's going on a separate rail that is not the minus rail. And I'm just going to hook this up to the minus rail. And you might see why in a moment. Go ahead and change this to black. What is which little brown thing? The one that's horizontal? Oh, this is photoresistor. Search for photoresistor or LDR, and you should get it. Yeah. The reason why they did this is because on this particular circuit, we also need to hook up an analog input. like so. So now we've got one leg of the LDR is hooked up to the resistor and is also hooked up to A0. And the reason why it's hooked up to A0 on that leg after the resistor is because this resistor is also basically just making sure that we're getting electricity down this way whenever the circuit is complete. Like, we want to make sure the electricity travels down to A0 in order to get input. Then we're going to hook the other side of the LDR up to the plus circuit. We're going to turn this thing red. Whoops. And we're going to hook, what is it, 5 volts? It's 5 volts. We're going to hook 5 volts up to the plus. Make that red. And we're going to hook the ground up to the minus, just like we've done before. That shouldn't be anything particularly new. But hopefully that all makes sense. It's a little confusing here because the red wire is actually going over this connection that the black wire is on without actually touching it. But as you can see, we've got power coming from 5 volts. It's running down here. It's going into the LDR, and we're having the LDR send everything back out through A0, because if it goes this way, it has to go through a 10,000 ohm resistor before it hits the ground rail. So basically, we should see a decrease in voltage as the surrounding area gets darker. Like, if you're working on this physically, if you put your hand over the LDR, you should see the number get smaller. Now, I say the number. I haven't told you guys exactly how to program this part of the Arduino yet. So let's go ahead. Let's take a look at that. How many of you are still working on the circuit, by the way? Raise your hand if you're done. Okay, and raise your hand if you're still working on it. All right, no worries. Just go ahead and spend some time working on the circuit, and then raise your hand once you've gotten it completed. Just waiting on. I curved the jumper cables. If you just click on an open area, you'll get like a little crosshair there, like an empty area, and then you'll put a bend in it. And it doesn't have to be a 90-degree bend. You can make it like this weird sort of mess. So you can make your circuit super hard to read if you were so inclined. I don't recommend it, though. Thank you. I know, it's super helpful right now. Although, the nice thing is it's not actually something you have to worry about making. So, this is actually an entirely useless jumper cable. Now I made a sweet bicep flexing. Anyway, waiting on a few more hands. Raise your hand if you're still working on it. Again, no shame in that. Just want to make sure that everybody's on the same page. Okay. Give everybody a couple more minutes then. I'm going to go ahead and delete my bicep. Nice. There, just so we're not confusing everything. Please tell me you tried to make that with the physical Arduino. Sitting there painstakingly bending a jumper cable to make it look like a bicep. Okay, so let's take some time looking at the code now too, because I want to make sure that we at least talk about serial print and stuff like that by the end of today. We can spend some time looking at the circuit one more time at the end of class, just to make sure that everybody's on the same page. But I want to make sure that we get the programming part of this done too. So, nice. The programming for this is super easy. It's really, really, really just silly easy. So we need our void set up and our void loop like we do with every single Arduino code. And all we gotta do, anybody remember what that does? I know it's missing a couple of things, but maybe if I put those in. How about that? Does that give you a clue as to what this line does? Yeah, make the. Hey, no worries, Matthew. Exactly, Jean-Marc. Yeah, it sets a particular pin to be either input or output. In this case, A0 set to input, because we are working with input now. And then, you remember how we had digital writes, and it was like a pin, and then it was either high or low, depending upon whether or not we wanted to turn a thing on or off? Well, remember, at this point, we're not outputting anything. We're waiting for input. And it's not digital, it's analog. So instead of digital write, we're going to say analog read A0. Just like that. It's a 0. So yeah, this is not AO, it's A0. Just like A0. This is pin A0. Yeah. Okay. So with that, we're done. This is the code made to make it read something in from this based on whatever you get here. And that's it. Really and truly. Here, let me put this into the code editor and a voop. Replace, upload and run. And it's working. Right? Yeah. Seems to be. I can do this. I can change the LDR. Nothing's on fire. But nothing's happening. Well, okay. Rest assured, we are actually getting input into our Arduino. Believe it or not, we are. We're getting input. But we're not doing anything with it. We're just giving the Arduino input and it's going, okay, like I'm reading this. And it's sitting there going 5, 3.2, 1, 2, 1, 4.5, 5, 0, 1. I don't know why the Arduino has that voice, but it does. And it's just dutifully reading from the input, but it's not doing anything with it. Yeah, I'm not entirely sure what that was. I'm going to be honest with you. I don't know what I was going for there with that accent, and then I don't know what it was supposed to be, and I don't know what it ended up being. Anyway. Robot, that wasn't quite right in the head. Well, I guess I hit it right on the mark then. Perfect. That's an Arduino through and through. 1.2, 3, 5, 4. Anyway. We need to do something with this input. I mean, like it's like we wrote a program and the computer goes, enter a number, and we put 2. And then it says, enter a number, and we go 4. And then it says, enter a number, and we go 3. And then it says, enter a number, and we go 7. And nothing else happens. It just constantly asks us for numbers, and we give it numbers. What a boring program. At least have it do something with those numbers. But sometimes, you know, yeah, right? Sometimes it's not always immediately apparent what the Arduino is thinking either. In this particular case, we're asking for input. What if we did something like we sent it some output that we don't immediately see? Well, we need some means of being able to look inside of the Arduino's brain and see what's going on. Enter. Serial print. Next slide. Haha. It allows the user to view the data that the Arduino is processing. That's amazingly useful. We can, in real time, look at brain surgery. Well, actually, did you know, that once you get through the skull, there are actually no pain receptors in the brain generally. So you can do brain surgery on somebody who's perfectly conscious. And in fact, a lot of times it's recommended because they poke around and they go, okay, like, is anything weird happening now? Be like, well, I suddenly remember my childhood a lot better. And they're like, okay, so we found some part of the memory center. What do we do this? And then their arm like goes up in the air. And they're like, okay, so we hit the motor center for the right arm. But it can be useful, actually, to keep somebody awake during brain surgery so that they have an idea of what they're poking around with. Yeah, no, that part doesn't feel too good. But, like, you know, with a lot of local anesthetic, yeah, you know, it's just working on the brain. It's something that's been done in the past before. But yeah, it allows for the it's not something that happens very often. Um, but yeah, it can be a very useful thing to do. It's a very useful diagnostic tool. Very, very ridiculously useful. Ooh, gnarly. Were you there when it happened? Oh, okay. I was gonna say, like, whoa. Anyway, we've got two commands which we can utilize for serial print. We've got serial.print, and then we put something inside the parentheses, and it will print out whatever we put inside the parentheses. Nice. Yeah, I can imagine. So we got serial.print, which prints out the thing, and then it just prints out the next thing right after it. And then we got serial.println, short for line. So serial.println, which will also print whatever is inside the parentheses. But then as soon as it's done printing it, it will do a line break. It will basically, like, you hit enter on the keyboard when you're typing something in Word and it goes down to the next line. That's exactly what it does. Here, it goes down to the next line. So in case you have multiple serial.print lines all listed there, they'll all print on their own separate line. This makes it much, 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 much more readable. And you might be going, well, this one sounds obviously better than print. Why would you ever want to have print? There are cases in which print is more useful. Say you want to print out multiple points of data on the same line. You could do serial prints, like 4 or 5 serial prints, and then the last one be a serial print line. So everything gets printed, and then you go to a new line, and then everything gets printed, and you go to a new line, and everything gets printed, and you go to a new line, and so on and so forth. So you're not always necessarily going to be using just serial.println, but it is a very useful thing. So let's go ahead and add those in there. So we've got our code, which we already know about, and it's already a thing. We need to set up the serial output first. And that is done with serial.begin. Begin, not being. Now notice how this is a capital S. Anytime we're referring to the serial class in Arduino, it has to be a capital S. So this is serial.begin, and we're going to say 9600. That is a lot of forward slashes. It's a lot of forward slashes. Found out that you had a focus on the GoToWebinar window and you didn't realize. Yeah, I love it when that happens. Okay, so serial.begin 9600. What does this 9600 mean? This is basically the bit rate that the Arduino uses to communicate with the computer. It has to do with the amount of data it will send at any given time, the amount of data that the computer is looking to parse at any given time, stuff like that. The higher the number, I believe the faster the Arduino transmits, if I remember correctly. I could be wrong. It's been a while since I've actually messed around with the serial.begin. So it's entirely possible that I'm wrong. Anyway, it could be that it prints slower but larger chunks of data, which would also make plenty of sense, like a lot of sense, almost the most sense. But anyway, yeah. So serial.begin 9600. And this sets up the baud rate, the transmission rate that the Arduino sends information to the computer. Now, if you're doing this with a physical Arduino, there is an important thing to take note of. Let me go ahead and get the Arduino program opened. Un moment. This is only for the people who are working with the physical Arduino, keep in mind. So, if we go up here to Tools, and we go to Serial Monitor, you need an Arduino plugged in. I can't show it to you right now. Well, at any rate, there is a little drop-down menu. Oh yeah, I forgot about that. uh, it was a dissertation. um, anyway, that's okay. So that's another thing. This might be part of the reason why having doing this on the website might be easier, because this is different for each person's computer. Like a couple of years ago when we did this with physical Arduinos, we devoted an entire class or two to getting everybody's Arduinos communicating with their computers, because it's highly dependent upon operating system and chipset, and it's even beyond that, it's very finicky. Sometimes it just feels like it doesn't want to communicate with the computer, even if it was working 5 minutes ago. I apologize. I was under the assumption that you guys already knew how to hook these up. We can spend next Monday going over that for all of you guys, because does everybody have an Arduino from Mr. Dubik? Okay, so everybody has one? All right, so let's do this. Monday, we are going to spend the class getting everybody's Arduinos communicating with their computers. How does that sound? Okay, let's devote that then. Let me just get this. Let me get this last bit done, and then I can show you the serial monitor. All right, so serial.begin, and we're going to say serial.println. What are we going to put in here, though? I suppose so. We'll see. We'll get a feel for how long it takes to get everybody's communicating. If it ends up being a little bit like if we get really super lucky and everybody's able to get theirs talking to their computer on Monday, like in the first 10 minutes, then obviously we're going to spend more time on Monday doing other stuff. But if it ends up being one of those things where it's like, oh yeah, mine is doing this and mine is doing this and mine is doing this and mine is doing this, yeah, we might just end up spending the entire class just troubleshooting everybody's Arduinos, in which case if yours is talking, you aren't required to stay here. All right, so yes, serial.println, but what do we print? Well, we can do this. We can say int LDR equals analog read, AO, A0. So right now, we set up an integer variable called LDR, and we're setting it equal to whatever the value is that is returned from analog read of A0. And then serial.println, we're just printing LDR. So we're printing out that variable value. Now, this would be good enough. Your Arduino would do exactly what you want it to do with this alone. Now I'm going to show you a thing that is going to compress it a little bit more and make it a little bit, at least, easier to read, in my opinion. And that's that. So what we've done is we've eliminated the middleman. Initially we had a variable called LDR, and we set it equal to the value of analog read, and then we had serial.println, print LDR. But otherwise, LDR was entirely useless. LDR just held the value of analog read for all of like a fraction of a second, and then it would just get demolished. So why spend time creating a variable that we're only going to use very quickly and one time instead of just feeding the value directly into serial.println? So that's what I'm going to do here. You don't have to do that. You can use LDR. It's always good practice to get more familiar with variables as well. But in case you're so inclined, you can do it the way I did it as well. So I'm going to go ahead and paste this stuff in here, and I'm going to put this into the chat box as well so you guys can compare your code to what I've got. And if I hit upload code, upload and run, and I click on the serial monitor over here on the right-hand side, as you can see, we're getting 54, which is 54, 54, 54, 54. However, if I start turning this towards the light, the little light icon here, you can see that the value is increasing. 954, 969, 974, and then we hit 974 pretty much at max value. So that value is the voltage that A0 is reading. As we decrease the resistance, the voltage increases into A0, thus giving us a larger number. Now it's not reading 974 volts. There's a little bit of internal math that our Arduino does. Because we're only sending out 5 volts. It would be really interesting if an LDR could actually be so low resistance that it multiplied the amount of voltage going through it. That doesn't really make sense. But anyway, it's a weird sort of internal math that Arduino does. So you can have greater granularity between values. So if I just, and then I can turn it all the way back down to the bottom and go down to 54. I can turn it like middle-ish way and get 937. We can go to like right here and get 841. So on and so forth. Anyway, 1023, that probably has something to do with how it's hooked up. You're probably just getting full voltage to A0. You're all 5 volts to A0. And there's something wonky with how your circuit's set up. So double check that stuff. In the meantime, though, it is 7:55. I have to do the poll questions. I have to do the question and answer time just to make sure that we can at least get that in before you guys have to go to, or before I have to do my other class. Sorry. And before you guys, head off and do your own thing. But anyway, so we're going to get that started right now, and then we'll do a really quick question and answer time. I got to bounce out of here about 7:57, 7:58, just to give myself enough time to set up for the other class. But let's do that.